So, welcome everybody to today's session, which is about REST, pragmatic REST, and designing a web API. So, the idea is we offer a web API to the consumers, and we want to do that in the REST style. And I want to explain what that might mean for us. We're going to look at what is a web API in general, what is REST compared to SOAP, how to design a web API, which also goes for most of APIs in general, some good practices, and some advanced topics that we won't touch today. We can touch them in a different session, or you can read it. That depends on your interest. Web APIs, as any API, is an interface to my application or my system. So it's a way for the consumers to access my services and my data. And it's a separation of the actual system and how it's accessed from outside. And often I have a couple of web APIs even for different contexts, purposes, apps, functions, different user groups. And why would I do a web API? Well, obviously it's in the web. And typically today all devices are connected through the internet, usually HTTP. This is why web APIs have become very popular. Can be used across all devices, both on server and client side. And it's typically also lightweight. I mean, it doesn't have to be. But typically, if you talk about web API, the idea is that it's lightweight, especially considering mobile devices that still often have bandwidth limitations.
So lightweight in the sense of the response size, or in which sense lightweight?
I meant the response, and basically the data that you send back and forth between client and server. And this idea of read and write anywhere is what I just mentioned, that you can basically access from any device and also write the web API on any device or host it on any device. Also, web APIs have this idea that they are self-documenting. So usually you find a documentation, but everybody has this experience of, well, do you really go through a documentation until you run into a problem? Usually you just try. You look at the response and the data and you just go try. So web APIs have this idea to be self-documenting. We're going to look at a few techniques today how you can help achieving this. Of course, web APIs also play a role with this new approach that we've talked about many times, which is microservices. So if you have microservices, they are going to have some API, and naturally it's going to be a web API. REST is an architectural style, and it actually stands for representational state transfer, which means we're dealing with resources. And resources are real-world entities. I'm going to say a few more things about that in a second. And these resources are shared in the sense of exchanged between client and server. So that's very clearly one of the fundamentals of REST. We have a clear separation of concerns between client and server. Also, we have a uniform interface. That means as a consumer, I should not be surprised by different formats and other kinds of variations when I send requests. So I should always expect to have the same design of how I send a request and the same design of the results, for example. And especially if I access the same resource, it should never be different and not in different places. It should always be the same. It should be cacheable, which means that the server should actually pursue some aggressive caching techniques. So you would send certain requests, like you want, for example, events or any kind of data in a certain time frame. And one of the principles of REST is that you cache such requests, either as long as the data hasn't changed, or you just cache it as an assumption for, let's say, 30 seconds, for example, but that's implementation details. What's really important here is just to say that cache as an idea, as a style, asks you to cache results. It's definitely has to be stateless. So if I send a request and I send it again, then my previous request cannot affect my next request unless I have, for example, changed the resource itself. Of course, that's something that might change, but it cannot, a request cannot in itself depend on a previous request. It has to be stateless. One thing that is really quite unique about REST is content negotiation. So the client instructs the server which format of response it would like to have. So we're talking about things like XML or JSON. That is actually something that the client asks the server to do, and of course, client and server might have a different set of possible content formats or response formats, and that's why typically you give a couple of formats as a client to the server that you accept, and this will be handled by the server in descending order. So it tries to take the first, if it doesn't support it, it will take the second, and eventually it usually falls back to some default. Another really a feature that REST is known for is the use of HTTP verbs, which means that we're using a, if you will, meta or header value of HTTP requests to decide what the request is actually, what kind of operation the request actually wants. So do we want to retrieve some data, do we want to update some data, delete? So it's not part actually of the URL or the URI in some shape or form. We're using this other dimension of HTTP verbs, which is the operation we want to perform on a result. So resources really are the target, something like an asset operator, a driver, a car, it could be a customer, anything like that, and the operations will be some transformation of that resource. Update, delete, or just retrieve it. As I mentioned, resources, I decided to add a separate slide for resources just because it's really a central point of REST. It means that I design my whole API around the idea of resources, which is a representation of real-world entities. You see a car, a house, or a person, and of course it could be anything else. And these resources are related. So a person might drive a car might be in the garage of a house. That's all something you also know from relational models and everything, but resources don't have to be, and usually they are not strictly or as strictly related as a relational model. It really depends on the scope and the purpose of the web API. So you might have resources in your API that are actually different to what you usually use internally in the model. Because you have your consumers in mind, and they might have a different kind of perspective on the data that you have. So they are related, and this is also part of the response. You see that? You see the relations in the response? And resources are represented in URIs. That means if I want to access any resource, it's available in one or more URIs, but it's definitely accessible by that, and it stays accessible. It doesn't change. It has some form of ID, some unique identification, and if I want to do anything with the resource, read it or change it, that's done by accessing some URI. I assume everybody has heard of SOAP. Most people don't hold it in very high opinion. So REST and SOAP, I mean, it's not about, like, I don't know, cleaning the rest with some soap. It's actually two terms. That the one we already explained, and SOAP is usually compared to REST, although actually that's not even a fair comparison because SOAP is or tries to be a protocol and REST is an architectural style. So that's not actually quite the same. However, they are both used in the web and they are, you could say, both web APIs. What they have in common is they use both an URI. So you want to access something, you use this URI. But in SOAP, we have the verb in the API or in the URI itself. So you would have something like get customers or change asset. Whereas in REST, you just have asset or customer, and the verb decides this get or update. And SOAP has some advantages depending on what you need. So it's transport agnostic. It doesn't have to rely on HTTP, which also means we can have stateful operations, which it also means we have built-in security, and that makes generally setting up security easier, and it's standard in SOAP. So generally, if you don't care at all about that lightweight in the sense of response and request size that we talked about earlier, then SOAP can be actually pretty interesting if not having to rely on HTTP, but security and stateful operations are important. If that's the situation you're in, it can be actually pretty interesting. Another point is that with SOAP, you can generate proxies on the client side. So that means you have what we call in REST these resources, which have usually certain properties, like ID, name, and configuration, and so on. And in SOAP, you can just, with a client, you can retrieve this definition of the resource, and it automatically generates a class in your client code, which is something that I've seen that people try doing something for REST is in a similar sense, that you have something like a schema definition for REST resources. Because what it means is if you want to deal with any response, in SOAP you just say, okay, serialize this SOAP response into this class that you auto-generated for me. In REST, typically you write your own class. You do it manually, or you don't even create an object. You just do it on the fly, whatever. So that's two very different approaches, and it's good to know about that. The last point, what I mentioned already, REST uses content negotiation. This is not something typical in SOAP, to do in SOAP. So the most, I think, important and interesting part of this session, which is designing a web API or an API, is the part that we're going to talk about now. This is an overview. I will show you a slide for each of these points. So we will look at designing the URI, how to access a resource. What are actually standard HTTP verbs? What do they mean? Status codes. How should I design a result? We have a look at associations. This is this relation between objects. And finally, paging. So resources should be nouns. We already said asset, customer. However, they should be plural. So that's best practice. That you don't say asset, but you say assets. And then the verbs are operations, as I already mentioned. So you don't find them in the URI. You don't say get assets or get assets. They are not there at all. And also be smart about identifiers. So in the lower part, you see assets, which we see in both cases. And the first case will give us all assets that are available. In the second case, we're going to get one specific asset, which is called private jet. So this private jet in green is the identifier of that resource. And what I mean by be smart about it, don't just by default take the ID, something like the unique ID or sys ID or even a global unique identifier, which is like, I think 32 byte or something. It can be anything that you want. Of course, it has to be unique. But typically, for example, in blog posts, you will find the date with the blog title, or just the date with a minute timestamp to it, maybe. So that can be anything that is unique and that makes sense to your consumers. So the point here that you should take with you is just don't just by default take that ID that you have from the database. Think about some identifier that makes sense and that hopefully is not as long as auto-generated IDs. The next point that I want to look at are these HTTP works, which the standard ones and most commonly used ones are get, post, put, delete, and patch. So get allows us to retrieve one or more objects. Post allows us to create one object. And put allows us to change an object, to update an object. Delete obviously deletes one. And patch is partial updates, which I will also address later. But what I want to talk about now is this grid that we see here, this small table with just 2 rows, which shows us the differences for all assets and this private jet asset. This asset called private jet. So for get, I will get a collection of all assets for this asset. For post, I will create a new asset. With put, what I'm gonna get is a status code, whereas as we just saw for post, the standard is to return the newly created object. And for delete, we're gonna get an error response. That's why it's red. Because you cannot delete all resources. That's just another default in REST. You do not allow to perform a delete operation on all resources. Now, if we go to the single resource, which is private jet, with get, obviously we get private jet, the asset. Post, we're going to get an error response again, because it doesn't make sense to create an asset on a specific asset. You would do that on the assets collection. Put is going to update our asset, and we're going to get back that asset. And for delete, we are going to get a status code, which if everything went well, that's a 200. And if something went wrong, that's going to be a different status code. So, status codes. Look, this is an important feedback for the consumer. Because if you rely on something like response texts, then it's hard to automate. Then you're going to find code that says something like grep certain keyword within the response text. So it's much better to use these status codes because they are hardcore. They have a defined meaning, and it's a very clear contract between consumer and your API. Typically 200 should be returned very often because it means everything okay. The 201, the created, is the one that we're going to get back in this case. So we create a new asset. People that do not care so much about the consumers, they would just return a 200. Because, yeah, it's not wrong, but actually, if you want to write a good API, you would return 201 for object created or resource created. 301, this has something to do with caching that, again, I will address a little bit at least later. But basically, you want to know if a certain object is still in the state that you know it to be as a client. And in that case, you're going to get back 304. Yep, it's as you know it. 400 means you did something wrong in your request. At least that's what the server thinks. 401, you're not authorized. That means you have not logged in yet. And 403 means you're logged in, but you're not allowed to do whatever you want to do. And 500 means somebody should fix a bug on the server. Let's look at the result design. The first box is representing a single resource. So we see a JSON response in this case, which is not what I want to explain to you, that the result should be JSON. It's just I chose JSON to be consistent. And you just see 3, well, basically fields, which is name, ID, and status. Nothing much to say about this. You just get the representation of the resource. If we have a collection, it's a good idea to add some meta information and to not just add the objects in the response itself, but to give information like total results. So in total, we have two assets, the private jet and a penthouse. And then you wrap the actual results in a field called results. You don't have to call the fields total results. You don't have to call results results. That's not the point. The point is that you provide some extra, some meta information outside the actual results collection. The other point is associations, which means I have two resources and they are somehow related. Again, we have this private jet, and drivers is actually not really right. It should be pilots. However, let's just assume you can just drive a jet and then somebody else is going to fly it, which will be, in this case, lumberjack. So what you see is that there's a collection of drivers, which is our lumberjack. Now, you might want to know, why have I repeated this same response in the bottom? This is to show you that if you use associations, so you show the driver of the jet here, and you show the driver as its own resource, it should be the same. It should not be different. You shouldn't suddenly have name, full name or something. It should be exactly the same wherever you see this resource.
I have one question.
Sure.
If you can go up one again.
This one?
You said, yes, you said that it's, there's this field total results too. I was wondering why you would put this in, because usually when you read something like that, then the code will create some kind of, in this case would, for example, create a result, for results would create an array, then you can ask the array itself what size it has. This is just redundant information and might even be inconsistent. Is there a particular reason why you would do that?
The two reasons I know, and it might not be all that there are, but the two reasons I know is that you can, depending on how the client works, you can prevent parsing the whole response if you're just interested in how many there are.
Okay.
So you save some computing time.
I see.
And the second I know is paging, which of course here we don't have enough information, but if you add paging relevant information, then it's gonna,
I see.
it's helpful. That's the two reasons I know.
Yeah, okay, I see.
Okay. Paging. So in this case, I've added total results, which is 3. So we have 3 elements. We have total pages 3 because we show 1 element per page, just to make a point here. And we're currently on page 2. Now the results apparently is again our private jet, but there's something else that's interesting, and this is previous page and next page. So here you can actually navigate to the pages with HTTP links. And this is one of those points that I mentioned with self-documenting. You do not need to know, or you do not need to read the documentation for how to do paging between, or how do you do the paging for this collection. So through a uniform interface, you would expect that you always have a page parameter in the query string for all resources. That's one. So you don't need the documentation for that. And secondly, since you can nicely navigate here, you don't need to read some form of written documentation to know how to navigate through the different pages. The other point here is actually you see that we use a query string. We haven't done that yet because we've used the URI to access the resource and we have used verbs. But if you go any further than using put, post, patch, delete, whatever, then the good practice is to start using query string parameters. Not, for example, what some people thought, creating your own custom HTTP verbs. So if it's anything complex like paging, complex in the sense that it's not covered by the standard HTTP verbs, use query string parameters.
I have one comment on this. I know it that you don't use the full URL, but only the relative part, because yeah, I basically got killed by one admin because he was using a load balancer with a different URL. If you put the full URL in it, then I mean, this is one big advantage of HTTP. You can, for example, go with a load balancer, you can do URL rewriting mechanism or something like that, so you don't need to know where on which machine this stuff is. And basically, you don't need to know, and you don't know. I mean, you shouldn't know, maybe. So you can hide it. So if the system puts a URL in it, then the whole concept of redirecting proxy or whatever will not work anymore.
I mean, if you have a scenario where the URL actually changes, which is not a must for load balancing, obviously you can do it at a later stage, but in that case, it would probably not be the best idea to have absolute URLs. Yeah, no. I agree. So that's something to consider during the design.
I remember that I was once talking to an IT guy, and he said, "Are you stupid? Why are you doing this?" And he said, it was not my fault, but like that approach.
That's really, I mean, if it's relevant, then it's good to know at this design stage. That's good input. Okay, that was that point. And we jump to the good practices. So we have designed this API. Why? Because mainly we want to make it easy to use for the consumers. Because frankly, you can try to impress people at conferences, or you can try to, I don't know, get some high score in some REST freak forum. But is that going to make your API successful? Probably not. So the people that, or either the machines or the humans that consume your API are the people that are really important. So this design should be made with having them in mind, so to make it easy to use and to make it popular or successful. This good practices is partly summary, but mostly I've just tried to add some new points that I didn't go into details further, which consistency is one of them, and it embodies this uniform interface that I mentioned. It embodies, of course, that you have always the same response format, that you have always the same URI design, and all that we've seen. So be consistent. Use partial items. Partial items we can use for both get and patch. So the idea is that in a query string, as we saw, you can specify the fields that you actually want to get from the server. So you want to see an asset, so you can specify I'm only interested in the name. The same if you want to update an asset, and you only want to update the name. Why send all the values? So also you can specify the field in a query string parameter. When you run into a situation where you need something else than REST, then the recommendation is REST first. Okay, what is the situation that you run into? There are parts in your API that this resource approach is just not working. What if you want to say send or execute asset command? Or what if you want to say shut down server or reboot server? This is not covered by any work. So in that case, it's actually totally fine to follow this remote function called RFC idea, to have such a method, if you will, or such a command as a query string parameter that you execute. So you would have your asset and something like execute command equals command name, or just reboot server equals true, or something like this. And then in that case, don't try to kind of bend over backwards to make it REST conform. You can add this based on your RESTful API. Is that clear what I mean?
What's going to be the verb of the HTTP request for that request?
You mean the verb?
Yeah, for the non-couple operation.
As far as I know, it should be get, but I'm not sure. That's a good question, actually.
Definitely often used, but I'm not sure if there's a kind of standard on that. But I've seen it very often.
Caching with e-tags. So e-tags is an ID of a version of a resource, very simple. So you have a long number that says, okay, this long number represents the resource in this version. So the server might return this number, or this ID, or string, or whatever, to the client, and the client knows, the state of this resource that I know is mapped to this string, or this key. Now the next time I want to read either the resource or I want to update it, so read means I might not have to read it because I still know I still know the state, the current state, or if you want to update it, then you might use it for optimistic concurrency checking. So you send, okay, I was updating the object with the assumption that this is the current state using the key. So for these both cases, you can use these e-tags, and the server can respond that, yeah, this is still the current version or it's not. So this is basically an agreement between client and server on how to identify the up-to-date version of a resource with this e-tags. And it's optional. I mean, the client doesn't have to rely on it. So if the client doesn't use it, then you could technically enforce it on the server saying if you don't provide an e-tag, I'm not going to return this, but I've never heard this, so it's something that basically is bound on is bound to the courtesy of the consumer. 3 more points. The third last offer reasonable result formats means you don't have to offer all possible formats like CSV and I don't know, binary and whatnot. Typically, you would look at JSON and XML. That's usually what you're interested in. Sometimes it might be Atom or RSS, if it's like a typical feed, but usually that's it. So often offer reasonable result formats that make sense and be happy with it. Return resource URLs when you return or when you in the design of the result format. So that means when we think back of our asset, we saw something like ID and name, but what we actually didn't see was some URL for the actual resource, like we saw with the previous page, for example. So it's a very good practice to return that URL. Again, think of self-documenting API, because you remember assets. Let's actually go back. Where was it? Asset, and then we see drivers. So what if I had a link here that would offer me the link to that driver object, and I could just click on it, or the consumer could just open the link, and we're at the asset. So that's a very good and helpful practice. The last point, create self-documenting API with everything that I've described today. So that's something really helpful to follow and avoids hassle. Finally, some advanced topics that you might want to look at, or you can also ask me about it, is REST security. So I mentioned SOAP has built-in integrated security, means REST doesn't. That doesn't mean you cannot do security with REST, but you have to do it. It's not going to do it itself for you. That's one point. How to do that is an advanced topic, which doesn't really mean it's too complicated, but there's some things you need to know. REST API versioning, so it should be a uniform interface, so you cannot just change the structure of your API. So if you want to change it, you need a new version. And how do you do that? There's a few standard ways. Actually, there's one very common way, and that's this topic. And the last one is a horrible acronym, how I find it's HADOS, which is Hypermedia as the Application Engine State or something. And yeah, I forgot. It's even But anyway, what it means is, it means that you use these links that we saw and other links to to be able to navigate through your through your resources, and also to perform some operations. So, for example, if you say you have an RPC call, deduct money from, or deduct €5, let's say, then you would typically offer a link in your resource to that operation, deduct €5. But the trick is, as soon as you reach less than €5, the link is going to disappear from your resource as an operation. So again, Hatos is another building block for self-documenting API, and it's done by using simple HTTP links for operations and links between, or associations between resources. That's all. Are there any questions left?
I have something about associations. So you showed that when you asked about the asset, you got the drivers. So you are getting the whole driver information. Or you said you can get a URL for the driver.
This was not an or. This what it meant was you should always return a URL for any resource.
Rather than sending the resource itself?
No, along with it.
But I was wondering, I mean, if there's drivers has location has geofences, and you're asking about assets. For example, let's say you have this. That means you will send all the associations with all the objects related to your just assets. You don't send a link or an ID or, so you are, you know what I mean? So if I'm asking for assets, would I, in asset drivers, would I get only just IDs and then I ask for those, or would I just the whole information?
So I understand the question, and it's what I think, just to make sure that everybody understands, is the idea is you have a large web of objects, a hierarchy related, and you're worried about the response size, basically. There's two things I want to say. One is, it's not only sending the URL or everything. I mean, either you show the resource or not. That's more the direction that is that I would recommend. However, for example, how Jira has done it, or Atlassian has done it for their Jira REST API, is that you have query string parameters with which you can indicate to which level of detail or depth you want to retrieve information. So if you're not interested in associations, you can indicate that with a flag or with some parameters in the query string. And of course, you can set that to be the default, that you retrieve only minimal data, and you will have to use query string parameters to get more in-depth information. So that's how Atlassian has solved this.
So I mean, there's no specific. You can develop your own mechanism to do this task. URL, you can return something on the whole object.
I mean, you can return only the URL, but again, I would remember the uniform interface principle. So I would at least think about it more than once.
I have a comment. As far as I know, that this REST principle has not been implemented in CISO Web Service, right? Are we going to implement that or to apply these principles in our CISO Web Services?
We have the let's say the infrastructure in place since for a while now, but we're not using it. So it's basically a matter of writing web services that use this infrastructure. There's no decision for or against it. It's basically up to the individuals. Writing it with REST in REST style or not. As you remember, we did this, for example, for one service.
There's only one service that used GET, as far as I know. and all the others use post. So when I create something, when I update something, when I delete something, I always use the post for so it's not REST at all. And if you could go back to the error, the STP error code, I think there is one more important error you should add it. It's the 404 for not found.
Okay.
That's one we definitely see the most.
Yeah. So.
Just a comment for these error codes, how they are so useful. I mean, when you read, for example, the logs from IIS, you will usually find them. And if, for example, you will say, okay, we only use 400 if there's an error, and we don't use not authorized, don't use forbidden or something like that, then it is very hard to read the logs. I mean, there are so many tools in the field that will analyze log files and look exactly for this stuff. So then you can do better analysis on your log files. Otherwise, you have to write basically the whole stuff on your own, which is usually not fun.
Yeah, definitely. Okay. In that case, thank you.